I will create a video game that is going to be played
by 1 million users.
Wanna know how I know or how am I going to do it? I will tell you all about in this video. 1 million users means a lot of things, right? And all of those things have their own benefits, like money, fame, etc. But the reason why I'm going to try to achieve this can be defined using only one word.
And that word is proud.
I want to be great, and I'm tired of not trying to do so. That's all. That's the reason why I'm doing this. So how am I gonna do it? First of all, I will write all the code myself. Again, I am too prideful. My pride doesn't allow me to let AI write code for me, or even use libraries or frameworks or game engines, none of that. I basically want to be able to say,
I built this in a cave with a bunch of crops.
I will only be using GLFW because I want to handle Windows without worrying too much about the operating system. And I'm going to use GLM because I already know much of the math that I'll be using, and I don't want to rewrite the whole thing. So do I even have progress so far? Of course I have. Otherwise I wouldn't be even dedicating time to making this video
instead of actually coding.
I have one triangle. Actually, no, I have two triangles. And they rotate. And if you have two triangles, you can have cubes. Cubes. And if I draw cubes, I can draw anything, like a wizard, for example. I can also make the wizard move if I want to. And if I can do all of that, I can have a bunch of wizards doing a bunch of stuff. Now, allow me to tell you a little secret. Did you see those 6 steps I just mentioned? From the single triangle to all the wizards doing stuff?
Yeah, that's called a summary, right?
It is for the people in the back that can't understand technical stuff. So for the people in the front though, I'm about to go a little bit more in deep on how I did all of this. First of all, you have to go through the whole 600 plus line of Vulkan to draw a single triangle. You just can't bypass this, man. It is what it is. I don't know what to tell you. It used to be 1200 or something. They made it shorter, so there's that. Once you understand Vulkan enough and its hundreds of moving parts, you can just start abstracting each part into something that is easier for you to replicate or change. After all, it is on you to decide how things are going to be working. I, for example, divided rendering into 3 parts: default, animated, and debug. I won't go into too much details here because, you kind of need to be like a genius to understand all of this. But basically, I wrote 3 graphics pipelines, and the renderer switches between them depending on what is happening. The first is the default pipeline that deals with the camera projection and passing vertex color to the fragment shader. The second one is almost identical to the default one, but it receives animation data to figure out the current frame in the current animation. And the third one is a simple one that is used to draw simple debugging shapes. I know. Everything I just say sounded like gibberish to you. It happens. It happens to the best of us. By the way, speaking of drawing stuff, do you want to know how I am importing 3D objects into my renderer? It is a pretty cool technique called
I don't give a flip about how other people do this.
I'ma do my own way. There are so many 3D formats nowadays, and I hate every single one of them. They either don't have enough data, like OBX, which doesn't have animation data at all, or they have way too much data, like Alembic or GLTF. I don't even know how to pronounce that. I don't know if you know this, but Blender has this amazing Python API that gives you access to everything you create in the program. At the end of the day, 3D graphics are just a bunch of points called vertices that are connected by us, the graphics programmers. So with the Python API, we can just grab those vertices and write them into a file and read them in our render.
And boom!
We have our own custom 3D exporter and importer with only the data we want, nothing more, nothing less. Now, do you see those bones in front of my wizard? Those are used for something called a skeletal animation. For 3D character animation, this is kind of the industry standard, right? But as I mentioned before,
I don't give a flip about how other people do this.
The math and how all of that works confuses the heck out of me. Like, nah, seriously, like, there is hierarchy of bombs, which means some bombs are going to be transformed based on the transformation of another bomb. Just that alone makes my head hurt. So what I did is, in my opinion, something way more simple but elegant and perfect for the type of game that I want to make. In Blender, you can create multiple animations in the same mesh using something called actions. Each action has a list of keyframes or key poses, and Blender interpolates between them in a defined rate. So I can just export those actions as animation clips. Each animation clip has a list of key poses, and each key pose has information about the animation, but also have all the vertices in the model already moved for that frame. Then in my renderer, I create an storage buffer, which is great for uploading a huge amount of data to the GPU only once and read a lot from it. The storage buffer is a big array with all the vertex of all the key poses, of all the animations, of all the objects. In the CPU, I keep track of all the objects, animation clips, and key poses indices, so each object knows exactly where to look in the storage buffer. Now, because we only save the key poses and not all the frames, we can do the same as Blender and do linear interpolation between key poses each frame, saving us a lot of memory per animation clip. I know that the people in the front that has been paying attention will raise some concerns about wasting memory with this approach. At the end of the day, each key pose will have the full list of all the vertices of the 3D object. This is something that skeletal animation does better. But honestly, this is a good trade-off. I really don't want to deal with the skeletal animation at this point. I did the math, and if I have something like 50 animated objects, each one with unique animation, each animation with like 30 key poses and with 2000 vertices, I will consume less than 500 megabits of GPU memory. I really doubt that I will have that many animated objects, each one with unique animations. Like, I already designed this in a way that I can define one single animation mesh with all the animation for that mesh and have multiple objects using the same mesh. So if a wizard have like 10 animations, I can have 50 wizards, and I will still be just uploading 10 animations to the GPU instead of 15 or 500, because it's the same animated mesh. But honestly, all of this is to say that
I do whatever I want
because I have free will to do so. So yeah. But isn't all of this like super cool, like super impressing? Like, are you impressed? I bet you're impressed. I bet
that you're impressed. You're impressed, right? You are impressed, right?
And finally, how are the wizards moving around and doing different stuff? I mean, yeah, you could just write a bunch of if statements,
Like a caveman.
but I have never implemented an AI or an NPC in my life, so I did some research and find two ways of implementing AI in video games. One is called a state machine, and the other one is called behavior tree. I choose behavior tree because it seems super cool and scalable and something that can be read better when implemented well. Also, it uses trees, which is a data structure that I don't get to implement very often, so it makes my programmer brain very happy. Anyway, the way it works is that we have a decision node structure that can have pointers to other decision nodes, one called yes and another one called no. It also have conditions that needs to be evaluated to see which decision node to choose, yes or no. It also has an execution function. We can execute some logic before going to another node, or we can execute logic at the end of the tree. With that structure, we can define a binary decision tree and evaluate each frame, passing some data that changes each frame. With this, we can already create complex behaviors like the ones that you are seeing on the screen. This is so cool because I want this game to feel like it has its own life and its own goals without the existence of the player. The player should be just another variable in the game loop. So I am working on having wizards that already knows what to do with other wizards or other type of objects. So when the playing appears, there should be just something already happening. And well, that's everything I have so far. In summary, this is a C++ project that used Vulkan to create a 3D renderer, game engine, and game from scratch. You guys have no idea how much fun I'm having with this project. This is literally like a part of my brain being poured into something, trying to materialize a crazy idea that I have. In my opinion, this is why we code.